Imagine standing on the shore of an otherworldly beach, where the sky burns a deep crimson like fresh blood, fierce winds howl and tear through the air with unrelenting fury, and the ground trembles beneath your feet from raging storms that seem to shake the very foundation of the planet. Far in the distance, at the horizon, the sun appears as a faint, flickering speck of light, barely visible behind thick, ominous clouds that hang heavy and dark, as if it is desperately clinging to its last remnants of illumination before being swallowed entirely by an encroaching void of darkness.
Energy levels critical.
The crashing waves roar in harmony with the shrieking winds, composing a savage symphony of nature's raw power. This is not a beach on Earth but a scene that could exist on a distant planet, where beauty and harshness intertwine in a way that leaves you both awestruck and filled with trepidation. This might well be Gliese 832c, a super-Earth located 16 light-years from our home world, a realm brimming with promise yet shrouded in profound mysteries. To put that distance into perspective, 16 light-years translates to an astonishing 151,400 trillion kilometers, a vast expanse that underscores how isolated and remote this celestial body truly is. Hello everyone, today we embark on an extraordinary journey through the cosmos, delving into the grand questions about life that await answers. Is there a place out there where sunsets surpass the beauty of those on our own Earth? Could there be a planet with vast deep blue oceans, sprawling continents, and skies ablaze with radiant light, eagerly awaiting human footsteps? Gliese 832c stands out as one of the most promising candidates in this cosmic search, inviting us to ponder the possibilities of worlds beyond our solar system. The explosion of discoveries has revealed thousands of exoplanets. Let us start with numbers that inspire wonder and humility. As of now, scientists have identified around 3,221 star systems beyond our own, with 4,370 planets officially confirmed, and an additional 6,000 candidates under intensive scrutiny. These figures, though provisional, paint a picture of an immense universe where Earth is merely a tiny speck in an endless desert of stars and worlds. We are living in a golden age of cosmic exploration, an era in which, within just one generation since the first exoplanet was discovered in the 1990s, technological advancements have propelled humanity forward in leaps and bounds. This rapid progress includes sophisticated telescopes and space missions that have revolutionized our understanding of the universe, allowing us to detect planets through methods like transit photometry, where a planet's passage in front of its star dims the light slightly, or radial velocity, which measures the star's wobble caused by gravitational pulls. Picture enormous telescopes perched in arid deserts or atop lofty mountain peaks, tirelessly scanning the night sky and capturing faint signals from distant stars. Each signal tells a story, represents a possibility, and kindles hope for new discoveries. However, not all planets are equally easy to detect. Giant gas spheres like Jupiter or large rocky worlds known as super-Earths are more readily observable due to their significant effects on their host stars. In contrast, smaller planets akin to Earth or Mars hide elusive in the cosmic shadows, like precious gems obscured by the vast darkness of space. These detection challenges highlight the ingenuity of modern astronomy, relying on instruments that can sense minute changes over immense distances. Now, let us turn to our main focus, Gliese 832c, planet discovered in the year 2014. Situated about 16 light-years away, equivalent to that staggering 151,400 trillion kilometers, this world orbits a red dwarf star of type M in the constellation Grus. Envision a diminutive, dim star far fainter than our Sun, yet serving as the heart of a potentially rich planetary system. Gliese 832c resides in the habitable zone of its star, where temperatures range from -40 degrees Celsius to 7 degrees Celsius, varying based on its orbital path. This zone is often called the Goldilocks region, where conditions might allow liquid water to exist, neither too hot nor too cold for life as we know it. This planet is substantially larger than Earth. Its diameter is 1.5 to 1.75 times greater, and its mass is 5.2 times heavier. Such dimensions classify it as a super-Earth, a category of worlds that bridge the gap between terrestrial planets like ours and gas giants. But do not assume it mirrors Earth perfectly. Predictions suggest Gliese 832c has a dense atmosphere, possibly resembling that of Venus, with a risk of runaway greenhouse effects that could superheat the surface. Nevertheless, if conditions are not excessively severe, it might harbor ideal regions with liquid water, the cornerstone of life. Atmospheric composition plays a crucial role here. Models indicate potential for clouds, weather patterns, and even seasonal changes that could support diverse environments. Imagine soaring over Gliese 832c in a spacecraft. The sky appears reddish and hazy, with light from the host star only as intense as a full moon on Earth. Violent storms sweep across the landscape, thundering like endless bolts of lightning. Low-lying mountains, unable to rise high due to strong gravity, dot the terrain, while shallow oceans glimmer faintly under the subdued glow. Frigid temperatures prevail, but a greenhouse effect could sustain liquid water, forming seasonal wetlands. Rains, whether water or some exotic chemical compound, might fall frequently, evoking memories of primordial Earth, when storms and tectonic activity inadvertently seeded the origins of life. This vivid imagery draws from scientific simulations that model alien worlds based on known physics and chemistry, helping us visualize what exploration might reveal. The latest updates on atmospheric mysteries and life potential. As of November in the year 2025, researchers continue studying Gliese 832c using powerful telescopes like the James Webb Space Telescope. Recent data hints at the presence of water vapor and organic compounds in the atmosphere, though confirmation remains pending. A notable finding involves radiation signatures from the host star, but Gliese 832c's strong magnetic field may shield the surface from harmful rays, much like Earth's magnetosphere protects us from solar wind. Debates persist about tidal locking, where one side perpetually faces the star, causing extreme temperature differences. The day side could scorch like a desert, while the night side freezes like Antarctica. Such a configuration would create a twilight zone along the Terminator line, potentially the most habitable region with moderate climates. The planet orbits its star at a mere 24 million kilometers, about 2.3 times closer than Mercury is to the Sun. Its orbital period lasts just 36 days, meaning 10 years on Gliese 832c equate to one Earth year. The host star, Gliese 832, has existed for over 9 billion years, twice the age of our Sun, and is expected to burn for another 50 billion years. With such an extended lifespan, red dwarfs like this offer stable environments over cosmic timescales, increasing the odds for life to emerge, evolve, and perhaps even develop complexity. Earth's journey and hopes for Gliese 832c. Reflect on early Earth billions of years ago, engulfed in storms, volcanic eruptions, and primordial oceans teeming with chemicals. Liquid water emerged, dissolving minerals and sparking complex reactions that birthed life. Gliese 832c may follow a similar trajectory. Meteorites carrying organic compounds from space, humorously dubbed cosmic delivery services by scientists, could have seeded life there. These impacts are common in young systems and play a key role in panspermia theories, suggesting life or its building blocks travel between worlds. Experts believe that with a surface area 3 times that of Earth, Gliese 832c could serve as an ideal future settlement. Yet, we must first answer, does life truly exist here? If so, what form might it take? Perhaps microbial mats in shallow seas or resilient extremophiles in harsh conditions. The vast universe and its challenges. Our Milky Way galaxy harbors between 200 billion and 400 billion stars. But not all locales favor life. Many planets are excessively hot, cold, or immersed in radiation zones. Gamma-ray bursts from supernovae can sterilize regions spanning thousands of light years. Fortunately, the safest zone for habitability lies between 6,500 and 26,000 light-years from the galactic center, with Earth on the outer edge. This galactic habitable zone avoids the dense, dangerous core while benefiting from sufficient heavy elements for planet formation. Mars, secrets of subsurface water. Within our solar system, Mars tells a different tale. Once thought to have lost all its water to evaporation, latest NASA data reveals 30 90 to 99% remains trapped in the crust. 4 billion years ago, ocean's depths ranged from 100 meters to 1.5 kilometers. Today, water is bound in minerals, unable to cycle due to absent plate tectonics, unlike Earth's dynamic geology that recycles water and nutrients. The Perseverance rover, landing on the 18th of February in the year 2021 at Jezero Crater, hunts for ancient microbial traces. Equipped with 23 cameras, atmospheric analyzers, and the MOXIE oxygen generator, it represents the pinnacle of robotic exploration. The mission cost $2.7 billion, but every image and soil sample contributes to unraveling solar system history, potentially revealing if life ever thrived on the red planet. Titan and dreams of flight. Further out, Saturn's moon Titan is a wondrous world with an atmosphere 4 times denser than Earth's, liquid methane lakes, and organic compounds like C3H2 detected in the year 2020. It mirrors prehistoric Earth. The Dragonfly mission, set to launch in the year 2027 and arrive in 2035, will deploy a nuclear-powered octocopter to soar over dunes, rivers, and craters, seeking life signs. This innovative drone will hop between sites, analyzing chemistry in ways rovers cannot, opening new frontiers in astrobiology. Gaze at the starry night sky, those twinkling lights beckon humanity to explore further. Gliese 832c, Mars, Titan, each planet and moon is a narrative of hope. We may not have found life yet, but every cosmic step brings us closer to answers. Will Gliese 832c become a second home? Will Titan unveil life's origins? Only time and humanity's boundless curiosity will tell. The universe teems with potential, urging us to dream bigger, build better tools, and venture boldly into the unknown, where the next great discovery awaits.